So how do you figure out your vanishing points in two-point perspective? Well, it starts with standing position. That's why standing position is so important. When you plot standing position on your sheet of paper, you're going to plot it somewhere beneath your working area. Now I have a giant sheet of paper right here, so I'm just going to work on my sheet of paper, but I'm going to crop into a much tighter space. And that tighter space represents my plane of vision. Now, how far back do you plot your standing position? In some respects, it is arbitrary, but know, like all perspective, you're going to get certain results if you do certain things. So if I scoot up my little dinosaur dragon friend closer to his plane of vision, in other words, if I move my standing position closer, it's going to give me a different set of results than if I move my dragon friend further back. What do your vanishing points represent? Well, if your grid is represented as square one, right where you are standing. So if we put our dragon right there on square one, and the rest of the grid moves out into our perspective. And if you were to look straight down on square one, that square will be perfect in perspective. So that's where we start. So we'll start with a standing position, and we're going to start with the right angle right on that standing position. So here's our right angle. Now the orientation of the box that's in front of us is going to correspond with the orientation of the triangle from our standing position. So if our little dragon is looking at the box like that, I can put a triangle on that box, and I can move my triangle all the way back to where the dragon is standing. And then where that triangle lands, which is in perfect alignment with that square, with that box, I can trace from one end to the next to find my right vanishing point and my left vanishing point. Because the continuation of this line is going to end up somewhere on the horizon line. The continuation of that line is going to end up somewhere on the horizon line. And if I'm placing that triangle right on square one, and I was to trace that line from that triangle out until I hit my plane of vision, as I go up my plane of vision until I hit the horizon line, I will hit the horizon line at a point somewhere over here that gives me right vanishing point. And if I was to trace that line out until I got to my plane of vision and go up my plane of vision until I ran into my horizon line, then I'll come to a point over here which gives me left vanishing point. And that ultimately will give me right and left vanishing points. And so on my sheet of paper, the same thing happens. So I'm going to go ahead and thank my little friend right here for helping out. And now let's go see how that looks in real life. So first things first, what's the first thing you do in perspective? Establish your horizon line. Because I'm looking down on my floor in this particular drawing, I'm going to elevate my horizon line. And that allows me to look more down on something. If I were to lower my horizon line, my floor would be compressed, would compact into itself, and I would see less of my floor, and it would make grading more difficult. So in order to make the grading more, a little easier for me to work and maneuver, I'll elevate my horizon line. So that's the first thing we're going to do. Let's go ahead and take our little T-square here, just make sure everything's lined up. And go all the way to the top right here with a nice big bold blue line. That's going to be my horizon line. All right, so now I'm going to create a center of vision. Center of vision is going to be in the exact center place of my plane of vision. So if I have my plane of vision right here, the center of vision will be there. If I have my plane of vision here, my center of vision will be there. I'm just going to make my center of vision kind of right and smack in the page that I already have, just for simplicity purposes. But decide for yourself what's going to be your working area, and then center of vision should be half of that. So my working area is going to be approximately right here. My perspective is going to be a fairly even perspective. So let's go ahead and drop our center of vision down. And I'm going to make this fairly light. And let's do this in a light pencil, because I may want to erase it, because I don't necessarily need this line once I've figured out where my standing position is. All right, so it's against my line of gravity, my center position, that I'm able to place my standing position. So this line right here represents our line of gravity. It's also our center of vision. Sometimes you call it center position. It's along this line of gravity, it's along this center of vision that I can plot a standing position. So I'm going to plot a standing position about right there, which then gives me a working area up in here. Remember, your standing position is going to be outside your plane of vision, and I want my plane of vision to be up around this area, so I'm going to put my standing position right here. I can move it down here if I wanted, or I can place it wherever I wish to place it. For now, this is where I'm putting it. And then this gives me the ability to kind of move my triangle back and forth, look at the room around me if I want, and I can make some observations, and then move it on my perspective appropriately. So let's go ahead and put it right there. Right vanishing point, left vanishing point, and if I were to utilize the diagonal measuring point method, I would simply put my corner right here, my one end through my left vanishing point over there, and I would find a diagonal measuring point somewhere right there. But that's not what we're doing. Instead, what I'm going to do is I'm going to find measuring points-zah, and that means I'm finding two of them. So how do I do that? Well, each measuring point is going to be associated with a corresponding vanishing point. That's why we have two of them. And the way that you calculate where the measuring point should be as it relates to its vanishing point is that it's the exact same distance between the standing position and the right vanishing point. If I had a compass, I would simply put the needle part on my right vanishing point right there and the pencil part right here and swing it on up until it intersects my horizon line. I do not have a compass this large, so what I'm going to do instead is I'm just going to take my ruler, and you can do this with a ruler, a sheet of paper, or any kind of straight edge. Put one end on top of my right vanishing point. The other end, I'll just put my thumb on where it matches up with my standing position and just swing that on up. And where we get alignment, I'm just going to make a mark. If I have a sheet of paper, the way I would do it is take my sheet of paper, and we'll do this for the left vanishing point using a sheet of paper. Put my corner right on my standing position, make a mark right there, and realign this over here to find my measuring point there. All right, so what we get a point on the horizon line here. That is the result of swinging out from my standing position this way. So this gives me right measuring point because it's associated with the right vanishing point. And I get a point over here, which is found by swinging out my left vanishing point up till it intersects the horizon line, and this gives me left measuring point. All right, so left vanishing point, right measuring point, left measuring point, right vanishing point. This is how you utilize these points. In 1 point perspective, you would have a baseline grid, just like that. And it's along this baseline grid that you could make perfect measurements. And because this baseline grid is aligned with my plane of vision, because it's parallel to my horizon line, these measurements do not diminish on us. They do not recede into space. But in 2 point perspective, let's just say I was to take this grid, and this is 0, and then this is 1, 2, 3, etc. 1, 2, 3, etc. that way. This being 0, and I was to break this horizontal grid that I have and put it into 2 point perspective. So we're going to crack this line and move this line up this way, move that line up that way. So I'm going to go ahead and do that by drawing a line from 0 to right vanishing point, draw a line from 0 to left vanishing point. All right, so we have taken this line and we've broken it, and now we've moved it towards both vanishing points. What happens to these increments? Well, as those increments move away from us, we now know that they will get smaller and smaller and smaller and closer together as they approach that vanishing point there, and they'll get closer and closer together as they approach that vanishing point right there. And the rate at which they do that is found with these points right here. All right, so watch how this works. This is where it gets a little bit dicey, a little bit tricky. So really pay attention and follow along. So we want to find what this point looks like on this line. We want to find out what that point looks like on that line, that point, etc. So I'm going to take my triangle and I'm going to align my triangle or my ruler or whatever it is you're using. So it's aligned with my right measuring point. But I don't draw a line. Remember, all parallel lines go to the same vantage point, Benjamin's first rule of perspective. So the lines of the grid still need to go to the right and left vanishing point because they're parallel to each other. This is for finding this point on that line. So I'll line up my triangle, and instead of drawing a line, I'll just simply make a mark where that line intersects this vanishing line. And that represents that distance there. Now we'll do the same with number 2. Once again, align it with the right measuring point. And once again, do not draw the line, but just draw the intersection. And almost immediately, you can see what's happening. You can see the diminishing and compressing factor of perspective happening against this line. So let's do it with number 3. And you can continue however far into the distance you want, and you can extend and draw a baseline as far out as you need to. And now we'll go the other direction. So now going this way, finding this point against that line by connecting to that point. Make a point. Again, you're just making hatches on the line. These do not represent the grid. These lines do not represent the grid. They represent measurements. And now we are going to create the grid, and we're going to create the grid by connecting these points right here that we have configured. I think I'm going to use green for my grid, for at least the lines that are on the ground. So we'll go through that, and I connect not to this point here. Don't do that. Don't get confused. Connect to your left vanishing point. And we'll connect to our right vanishing point. All right, now we have a grid on our ground plane, on our floor. That's 5 units this way, 5 units that way. Now remember why we're doing measuring points. This is as opposed to our diagonal measuring point. Remember, our diagonal measuring point was somewhere in that area right there. And I can certainly have created this grid using my diagonal measuring point. But the reason why we're doing this is because, once again, we're trying to find the height as it relates to the width. So we're trying to find the height of this square as it relates to this ground plane surface. And what I have is I have this vertical line that's coming up and is aligned with the horizontal line right here in my baseline. As long as 0 connects right at that corner, then I can measure exactly the same distance this way as I do that way. And that aligns and makes my vertical measurement aligned with my horizontal grid. So let's just do that real quick. And we'll go 5 because we have a 5 unit by 5 unit ground plane square. So this is the height of this square as it relates to the depth. And in fact, in this particular perspective, it looks a lot taller than it is wide. And that's just because of how we are viewing the perspective. But that indeed is correct. So now I can go back to this point right here, and I can close off the space. All right, so I could create vertical grids along this surface here and along that surface here because I already have these marks. But one thing I have noticed is that if I do that, then I've got vertical grid lines on top of ground plane grid lines. And all of a sudden I'm in all sorts of a mess trying to figure out which is which. So I like to move things back to my back wall. So what I'm going to do is I'm going to create a vertical line right here. And then I'm going to extend this wall in perspective back to my left vanishing point. And you can draw all the way to the wall if you want, or you can just simply stop where you need to stop. In this case, I'm just going to stop where I need to stop, just for the purposes of making sure I don't have too many lines on top of too many lines. All right, so This is going to be the back wall of the room. And if we want to just finish that off, finish the space off, I'll just connect the top out that way. All right, so now my next step is to take these measurements and throw them onto this line right here, and then I could throw a grid onto this back wall right here. Next step is to take these markings that are along this wall right here and to figure out where they associate with this line right there. And the way we do that, once again, is just go back to this right vanishing point, put my triangle up against there, and I'm not going to draw all the way through. I suppose I could if I wanted, but if you'll notice, if I did, it would kind of get confused with some of these other ground plane lines. So I'm just going to make the mark on the back line right there, all the way up. So I get my 5 lines. Once I have my 5 lines, now I can take these points and connect them to left vanishing point to get the horizontal lines of this grid going that way. And again, I'm not drawing all the way to the vanishing point. I'm just drawing the lines on the back wall. And sometimes that's important, is we know that the lines go back to the vanishing point, but sometimes if you go all the way back to the vanishing point, you get a lot of lines on top of lines and it gets confusing. So one way to resolve that is just to simply draw what you need, but make sure that your triangle or your straight edge is lined up perfectly. And once I've done that, now I'm going to see where this grid line matches that grid line against this wall right here. And where these things happen, I can just draw straight up. Like that. So now I have a space that is 5 units up, 5 units that way, 5 units that way. With this information, I can actually make measurements within my drawing. Is something 3 units high by 2 units this way, by 4 units that way? Well, I can actually draw out all of that. So let's see what that looks like. So we're going to go 2 units, we're going to go 3 units up by 2 units that way, and 2 units this way along the top as well. And what do we say? Oh, 4 units that way to the end. Get us another vertical up. Finish that line there. There we go. And the top of this object, which we're not going to see a whole lot of. And again, remember why this happens? This happens because it's so close to the horizon line. The closer you get to the horizon line, the less of the top plane that you will see, until you're right on the horizon line, and then you see none of the top plane. At that point, anything that goes above the horizon line, you're actually looking on the underside of it. All right, so this is my thing, whatever it is. Let's say it's a looks like a dresser drawer. So 2 units that way, 3 units that way, 4 units that way. And now that has been drawn properly in perspective and according to measurement. And so that's why we come up with these grids. Is to, number 1, find the perfect square. That's very important, so you understand what that square looks like in perspective. But number 2 is to find these measurements at different locations within your space.